Good morning.
Good morning.
Just a minute. Okay. So, very much. That's what I want to say. So, till now, whatever we discussed on development of ML models, and before jumping into the other tools, I just want to give a heads up on like what is a deployment and how we need to consider a deployment of a ML model, and then what tools majorly will be involved apart from Python, and how we need to address like any challenges during this particular deployment initially after your model is finalized. So by the time we move to the deployment stage as per the CRISP data mining, so we have business understanding, data understanding, data preparation, and then modeling, evaluation, deployment, and then finally monitoring. These are the stages which we discussed, if you remember. But till now, whatever we discussed, that is up to modeling and evaluation only. But when it come and talk about this, the deployment phase, most of the data scientists will lack of this deployment process. So there is a gap between the data scientist and majorly the ML engineers. So the ML engineers are basically going to support the data scientists by deploying the models and also like monitoring them by using the proprietary tools available in the market. We have different tools available for monitoring also. So to monitor any ML model or health monitoring of the ML models, we have tools like Grafana and Prometheus. So Grafana is basically one of the dashboard tool which is going which is very popular in monitoring the metrics of most of the tools like Jenkins or a database metrics or any pipeline metrics, any CI/CD like pipelines which are running. I want to see what is the status of those pipelines. I want to see in a dashboard. So I can extract that pipeline metrics into Grafana and I can monitor them, and I can go and keep an eye on the monitoring of pipelines also. Similar to that, to monitor my ML pipelines. So a ML pipeline generally will involve starting from the data collection. After I decided what is my type of problem, I go and start building my ML pipeline by collecting the data and then trying to figure out which columns are required for the use case out of this data of rows and columns. And on top of that, once my data is collected, I will start the data pre-processing or preparation. So why we need to go for data preparation, if I ask you? What is the need of data preparation? How it is going to help? Who will answer? As we discussed about data preparation, what is the importance of data preparation in any ML project? Purni? Shruti? What is the main importance of a data preparation process?
To clean up the data, and if we have any text data, we need to encode
Correct.
it to
Agree.
numbers.
Agree. What is the importance or necessity we need to do? Why can't we directly go and use this data as it is? What happens if I use that? Because every model, if you remember, most of the models which we discussed, every model will expect the data in a desired form, right? Correct or not?
Yes.
My data, whatever I'm going to use for any model, before passing to the model, I need to prepare the data ready for the model. So the model which I'm going to build requires sometimes all categorical data like decision tree. Sometimes k-means testing, since it will have a like a calculation in the background, we may need to pass in the numerical form. So most of the algorithms will look for the data in a desired form. So we need to convert that during the data preparation. So that is the main objective of data preparation, or also called as data pre-processing. So the data pre-processing is a process where you prepare your data, which is ready for the model I am going to use. So 80% of any data scientist journey will they spend in the data preparation only. So right data preparation always will provide the right results. So qualified data is important. So that is the reason the data preparation process is one of the key process for most of the data science projects. So this data, once it is feasible and good to use, then the data data will be divided into training and testing. Correct? No. So we go with a standard process of dividing the data into 80% training and 20% testing. And if required, we apply with numerical data, we apply scaling also on top of that to bring the data into a normal form. And we pass that data by separating into X and Y, independent and dependent variables. So we cannot pass all the data as it is, because every model requires the data independent and dependent variables will be as a separate variables. X train and Y train, X test and Y test. So every model will expect the data in that form, which will be a numerical array. Which function will divide the data into training and testing? In which library it will be present? If I ask you, if you if you remember, we multiple models we built. In every model, we were able to use this particular function, which is a part of a module. What is the module and what is the function? You remember that? Which function is generally will help to divide the data, that too using random sampling? Purni, what is the function? You remember that? Shruti, no idea?
From scikit-learn, but I don't remember the function.
Scikit-learn, very good, correct. The library is correct. Scikit-learn in that model selection, correct? No?
No. Yeah.
In the model selection, we have a function called train test split. Is it correct? Do you remember the function? The train test split function will divide my data into training and testing, right? So we mention the test size equal to 0.2 or 0.3. That indicates my testing data is 20% and my training data will be automatically become 80%. So this 80% training and 20% testing data we will pass to multiple models here. And then we'll try to see which model is giving the better accuracy. We select that as my final model. Out of my 5 to 6 models, I may see one model will be giving the highest accuracy score, maybe random forest. So I will go and use that random forest model will be my final model. And that model will be used for the deployment stage. So this deployment, the time that as soon as you reach the deployment stage, by the time you reach, you should have the model ready. You should have decided which model to use. So every data scientist will try to do multiple experiments, and each experiment will have certain accuracy score, certain parameters, certain data, certain features, all will be unique to that particular experiment. And it may work in our machine. It is not going to work the same way in other machines. Why? What could be the reason? Assume that your model in your environment is giving you very good results, maybe 80% or 85% accuracy score. The same model, when the operation team, ML operation team started using, but they are getting some issues, or they're facing some challenges to run it. What could be the reason? There is a gap, right? There will be a gap, right? From environment to environment. Is it mandatory that the team which you hand over your ML model, the team is that they may not have the dependent libraries also, right? Correct or not? Maybe
Yeah.
my ML model may be using some third-party libraries, and those third-party libraries is not mandated to present in the other environment also, right? And we need to install them, correct or not? Only my code is not sufficient. I need to see how I can transfer or hand over the code as well as what are the dependencies. That is where we go with a containerization, a Docker container or a Kubernetes pod. This will try to allow us to combine the model and its dependencies. The model file, which could be in a say which could have been saved in a like a binary form, like pickle, we'll call it as pickle form. Dot pkl will be the extension of the model which I will save it, and I'll hand over the model file, and also whatever the dependencies like libraries, I will create a requirement.txt file, and apart from that, we also need to see the data version control file. So everything we need to hand over. Then only the operation team can execute or deploy that particular model successfully. Any a little change also will deviate. That will give the model to be failed in production.
Okay.
So the notebook, whatever we are running till now, should be moved to a Python script, and need to hand over the Python script to the ML engineering team who are going to use for the deployment. Generally, that is the process which people will follow. And apart from that, once after you decided the deployment plan, and you also need to see the ML code should be only part of the system. There are so many other as I mentioned, data dependencies will be there, and then version control, data version control, and then uh, the package dependencies, and then the files which we are going to the files which we are going to use for my model, like the Python coding files, and all need to be hand over to the like deployment team. So any like a model that you want to go and deploy, you need to pass all this information. So as I mentioned, data preparation, and then this is nothing but the training, which we call it as model and evaluation both, and finally go to the deployment where you go and serve the model, monitor, and if required, you will retrain the model also. So what will happen here? Algorithm selection. What algorithm I need to use, we will select here. We'll try to select the best, which is the best model for my use case. That will be like done in this particular stage. But here, what is the data required to select the best model, and what is the right data, qualified data, and qualified columns we will decide here in data preparation. And by the time you use the deployment phase, this both should be done, and this stage should have the final model file also. That will be hand over to the deployment team with some dependencies, as I mentioned. So apart from this, we also need to understand the feature engineering. So feature engineering is nothing but how to go and generate new features from the existing features, or you also will perform some activities such as scaling. We did some scaling, if you remember, standard scalar. That also part of the feature engineering. So we will try to apply normalization, and then data standardization, data scaling, data binning, missing value replacement. We all this will be done according to the use case. So as soon as you finish this feature engineering, the features which are required to build your model, that once that they are ready, and then we will try to start creating multiple versions of your model. That is usually done through MLflow. So my model which I created and which I am training may require the multiple versions, because the first experiment may not have given the accuracy I'm looking for. Maybe the second or third experiment I may have got the accuracy I'm looking for. So multiple times you will go and run this particular model, will train it and test it and evaluate it, and after that I will create a version number for that. So this basically done by MLflow tool automatically. So to reproduce, I will save my model information in the MLflow. What parameters are important? Which parameters I need to tune? For example, for decision tree, which parameters I need to tune to improve the model performance? For random forest, which parameters? For k nearest neighbors, which parameters? So for every algorithm, there are certain parameters which we can optimize. So that is called hyperparameter tuning. And log the metrics. What is the accuracy score? And how to go and track it for every model so that I can cross check later. And how to log the artifacts, the model file itself. As I mentioned, the pickle file, saving the model in the form of a .pickle, and how to even log that particular model file also, because that model file also will have a version. All these need to be tracked before the deployment, because once after you deploy your model, which version we deployed, we should have a clarity. So that is going to give you how good your model is production also. So the conclusion: a model that is not deployed is just a fancy PowerPoint only. So people who will just do the development work and they will not push the model to production. So their model will just can help as a PowerPoint, fancy PowerPoint only, because that you can explain to anyone. But until unless they will not use it, nobody will confirm that. So the deployment phase is going to generate the revenue, save the cost, and it will improve the user experience. If you do more, if you go and see most of the e-commerce websites, before 2000 or 2010, there was no any recommendation like systems or recommendation engines. So as soon as we got Amazon e-commerce and other e-commerce companies, the customer experience has been changed. One day delivery, same day delivery, and providing the customer feedback and providing the customer review, and then cross-selling the products. All these came into picture to improve the customer experience. And 10 minutes delivery also is there in some products. So the deployment process should should help the customers to save their time also. They should not wait for long time. So that will increase the revenue of any company. Sometimes it will reduce the cost also. So the model which you are going to develop, how you are going to productionize, that is important. Industrialize is important. So to industrialize or productionize your model, you need to deploy it. Then only your company will get some money. And model packaging is nothing but how you are going to save your model. In which form you want to save. To save the model, we have different methods. Pickle or Joblib are the two different libraries which will help to save the model. And the model, once it is saved, you will try to read it by in the other environment, and then you will load it, and you will again pass some new data for prediction, and you will leverage it. So the pickle farm or Joblib, these two farms are specifically designed for storing this ML models. And TensorFlow, which is a library from like Google, they also will try to help us when you build any model. They also will allow to save the model what you develop. PyTorch also is having some like immediate representation of your models by using the PyTorch module or PyTorch library, and we have a language called PMML language also, and which is basically predictive machine learning markup language. So some people will use the PMML also. So that is a language where your model file can be saved. But they are all old methods. The new method, advanced method, what people are using is the pickle format. So you have a package called pickle, will import that pickle, and then you save the model as a .pkl file. And the pkl file can be loaded in any environment, and then we can start using my model to act on new data. Maybe assume that I have a loan defaulter model which I built, and then I store that model with some name like loan defaulter.pkl. So I want to use it back. Then what I need to do? I need to say like load that model back. To load the model, I need to use the pickle specific load function that will load into a model variable, and then we can start using it. So that is how this particular the serialization of the model, which is called saving into binary form, is helping most of the ML engineers to automate their like model deployments. And coming to like the tools like the Open Neural Network Exchange, these particular tools physically designed for the deep learning models. So there's a universal format where people are using, and which requires a GPU, CPU, GPU, and TPU also if your model is very complex. So normal traditional like infrastructure is not going to help us. We definitely need a GPU and a TPU to process the kind of data which are going to use in most of the cases. And this is supported by all both Microsoft and AWS and Meta. All are supporting this ONNX standard format. So everybody, most of the people who are using in a cloud environment, they are using this ONNX model only. And next, Docker. Why Docker? So why Docker is important for any DevOps project, if you know. So what Docker will do? Generally, Docker is a container tool. This is going to combine your code and then libraries and then dependencies. All dependencies will be clubbed together and will create a Docker file with the instructions stored as a Docker file, and we use it for like creating a container, and you can reproduce any number of containers once you have a Docker file. So we'll discuss about the Docker in detail, but at high level, Docker is a container. Just 1 minute, guys. Just 1 minute. Sorry, guys. So the reproducibility. So how to go and reproduce my experiment? To achieve that, we create multiple Docker containers. I'll discuss about them and soon. A Docker is one of the software which is basically will help us to create a container for your model. So any idea what is a Docker by any chance already or no? Is the first time you are hearing, both of you? Purni, is the first time you are hearing or you are already working on that? Or Smriti?
I haven't worked on it.
Okay, okay. So I'll explain about it. So a Docker is a like a software to create a container. And what is a container? I'll discuss later. Then I don't want to confuse. So normally in DevOps projects, the application will be combined with the code and dependencies, and a file will be created, and that file will be handed over to the operations team to deploy it with all dependencies and other stuff. Similar to that, in the place of the application, we use a model. So that is generally will happen, and we are using the same approach here also. And scalability side, the containers or Docker containers are the lightweight running applications. We do not need a high-end infrastructure when you're deploying. We do not need any server or any kind of high-end infrastructure. So we can spin up them faster, and we can scale up, and we can do all activities on them very fast. So a multiple Docker containers can be orchestrated using a Kubernetes cluster. So Kubernetes is also another software which is very popular to manage multiple containers, and each container in Kubernetes terminology, we will call it as a Kubernetes pod. So a container is called as a pod. So multiple pods will be there in a Kubernetes cluster, and it will automatically scale up or share the resources to all these pods, and every pod will be one version of your model. So one model version will be one pod, and this pod will be running, and that will be used by the end user. So they will access through that running pod. So those pods sometimes will be they'll be down, and to monitor and orchestrate, Kubernetes is providing a cluster environment to maintain and manage. That also we'll discuss about. And apart from that, this is how a Docker file looks like with dependencies. You can see here. So which Python version I want to use in the client environment where I'm deploying, and what is my file name is nothing but app.py, and we will copy the file from the working directory. This is the directory or folder where my files are sitting, and this command is going to copy the first requirement.txt. This requirement.txt will contain all the packages that need to be available to run my model. So this will first install this command. This run command is going to install whatever the packages I mentioned in this file, so that the dependencies will be first completely installed without any errors. Once that is done, we are just copying the model.pkl file and also app.py file, which is my application where my model is running, and then we are just running that application as using Python interpreter. So these commands, this file, when you go and hand over to the operations team as a MLOps team, you also will use this, and you go and run this file, and it will create a Docker container. So this model will be continuously running until you kill it, and whoever wants to access this application, they can access, and they can pass some input data, and they can go and get some predictions back, and according to their requirement, you will go and attach the model final predictions to their running environment or a dashboard. That depends on the user requirement. So all this will be generally done as a step-by-step process after your model is ready. And this, when you are serving or deploying your model, serving or deploying both are same. The response, whatever you are going to receive as a user, you need to go and see. It can be a model can be executed as a web service, so that the user will input some data, and after they will input all the information, finally they will have an option to click a button, and they will get the results. That button will be connected to the final prediction function. So assume for a loan default application or a fraud detection application, you will give a user as a input form. So they will try to enter, or they will try to upload a file or connect to a database where all my customer transactions are there. And once my customer transactions have been extracted, and my model will collect them and try to apply the fraud detection model and try to see every transaction, it will mark whether it is a fraud or not. So that is basically we can build like an application. Same case for recommendation engine also. The recommendation engine try to recommend you what products, for example, it is a product recommendation. So my model will try to recommend. So okay, these are the products which you can choose. for your investment. And it's a chatbot. It will try to respond to your queries. So deployment of a chatbot is nothing but the chatbot will be running as an application in a web page, and it will try to prompt you, how can I help? Again, how can I help you? Then you will ask some queries and it will respond like a human with some knowledge in the subject. So all these examples you see, every use case will have a different approach in deployment. A fraud detection model can be deployed as a web service. A recommendation engine can be integrated with a product. A chatbot also can be integrated with a website, so that the user, whoever will be opening that website, will be able to see the chatbot, and it will prompt you to ask any queries. So you can ask what are the related queries, and it will try to find out information, and it will try to send the results back. All these are the type of online inference or online predictions which we receive as a response after you deploy it. And apart from that, we have batch inference also. A scheduled job will create and will wait for the job to be completed, and it will try to provide some results. Maybe I will pass all my customer information. Maybe I am running a e-commerce company or a telecom company, so I want to see which customers are ready to exit my business. So what I do, I'll pass all customer information to that model, and it will execute for some time, and it will try to mark each and every customer whether he is ready to quit the business, yes or no. So these kind of use cases can be used as offline batch reference, we call it as, because my model will be already present, and it will be faster compared to the online inference, because my data will be already available, and which we will directly go and see the historical data only. We are not worried about the like real-time data. But in online inference, you will directly deal with the online data which is available on the website. So on fly, a recommendation system will recommend you some products immediately. So that can be achieved through this online real-time inference. But the batch inference is for historical data analysis. I want to see what could be my sales next week, and I'll use the last month and current month sales, and I'll use that as input, and I'll try to figure out what could be the next month's sales. So this will fall under a batch inference or offline inference. And we have streaming inference also, where you will have a continuous data flow. So as I mentioned, to predict the money laundering transactions in my bank, I need to capture the continuous real-time data also. For that, we have tools like Kafka. On Amazon side, we have Kinesis, we have IBM RabbitMQ, we have like a event, like a hub in Azure side. All these tools, one of the tool we will use, and we'll try to capture the like predictions as a message in the message queue, and these messages will be used for final prediction. So IoT sensor anomaly detection, for example, I want to see which are the anomalies in my IoT sensors, so that I can identify which machines will go down. So in that scenario, this streaming inference is going to help us, because it will separate the application from the model. So we do not need a integration between the model and the application in this particular kind of use cases. And we also have one more type of deployment called edge deployment, where you will integrate with your iOS or Android mobiles also, and that is one way. And embedded, it will be embedded with the one of the tools like NVIDIA Jetson and Raspberry Pi. These kind of devices also will run the models sometimes if needed. So my model, when I'm building, it should be thoroughly tested on not only one environment, it should be tested in every device here, mobiles, like IoT devices, embedded integrations, your laptop, web page, everywhere. So we need to also see how the edge deployment can also help us. So coming to deployment strategies, we have different types of deployment strategies. We have like where you have the blue-green deployment, canary deployment. All these majorly will be we perform in the DevOps kind of projects. Similar kind of approach we will follow here also, where we'll go and use the strategies like recreate deployment and rolling update is another deployment strategy. So anytime your model what you deployed is not giving the result up to the mark, then you will do a rollback. So the rolling back is important to like bring your old model itself. The new model is not working fine, roll back it and go with the old model. That is one of the type of model which people extensively use. But the recreate is where you will use version 1 and version 2, and version 2 is good, then version A will be automatically replaced. So downtime is available here in the recreate, but in rolling update there will be no downtime. And blue-green deployment, which I was mentioning, this is basically like a switch. We will have two identical environments where the blue is the current live version and the green is the testing version. So people use this method also to deploy any application or model. People use this green like a blue-green deployment, and then once the green is tested, then we'll switch to the load balancer to green, and we'll go and try to make that the as a current live version. So in this particular type of deployments, the benefit is we'll have an instant rollback which we can immediately apply if something goes wrong. So this is also one method. And the canary deployment is basically the other type of deployment where you will try to roll out a new version to a small subset of users, not with the entire data. Only 5% or 10% you will try to pass and you will test it to test it high level. Maybe for one of my like e-commerce company, I built a recommendation system. So I will first test that recommendation system on maybe 5% of the customers, so that you will try to figure out any errors will occur, then immediately we can resolve. If my model is healthy, then I'll increase the 5 to 10 and 10 to 25, and I can go with 50% and finally 100% also. So any challenges will occur, we will have less amount of data and it will be easy for us to do changes and deploy faster. So this is also one type of deployment. So blue-green deployment, canary deployment are the very popular deployment methods people use, and another one is shadow deployment. So this is basically to test the real-time traffic people use. So any kind of like request you are sending through your like application as a deployed model, you will need to see how that the network traffic is like supporting here. That is also one of the type of deployment called shadow deployment. So one interesting important thing which we need to remember is how and who will maintain the infrastructure. So the infrastructure generally will be maintained by the infrastructure team, and we will reach out them for any kind of support. If I need a Kubernetes cluster, I need to reach out the team. If I need a Docker container, I want to build. You should need a Docker software to be installed. So all this you need when you are performing this end-to-end ML model development. And coming to like tools like Kubeflow and MLflow, these tools also helping to create the final models and which we can even deploy also. I'll discuss about K-serve in Kubeflow also and what the importance of that. So Sheldon Core is also another tool, but which is a licensed version where it will help us to build end-to-end ML models and build a MLOps kind of version. But you need to buy a license for Sheldon Core. So all these, whatever I'm talking about, all these are different tools: MLflow, DVC, Sheldon Core, Qflow, and then GitLab, Git Actions. Most of these tools are very quite common in most of the projects. So I thought to start Git, but I want to give you a high level overview on what tools generally a MLOps engineer will use. And one more tool called Feature Store also to automate feature engineering. And all this will be used until your model is deployed. As soon as my model is deployed, then I need to focus on monitoring. There I will deal with Grafana or Prometheus, or we have one more popular tool called Datadog also for monitoring. So people use any of these tools according to their choice. If a company is ready to buy or purchase a license, Datadog also is one of the popular monitoring tool. Or if at all my company is not ready to buy, then you need to go with open source like Grafana and Prometheus. But how to extract the model metrics and how to see and how to view them, we'll see once you go to the model monitoring tab. Clear? What is the model deployment now? Okay.
Yeah.
At high level. So any model you developed, at the end of the day, you need to deploy it for revenue generation. Without deployment, your model, as I mentioned, will be just like a fancy PowerPoint presentation only. Nobody will care what you developed until you showcase them and they start using it and get benefit of it. So our importance here is mainly on the deployment phase and monitoring phase also. If you do a proper deployment and proper monitoring, the client will get the better results and they will start using that and they will try to pass more data and they will try to optimize the environment to get better results. Okay.
Yeah.
So we have like so many tools available, but we cannot learn all these tools. Like cloud side, we have so many tools in AWS side and Azure side and GCP. So, but we are going to learn some of the open source tools which I'm going to discuss about, starting with Git on Monday, and then we'll go with one by one, and we'll try to see how we can leverage these tools and integrate one by one. And how to use the Git will be by default available. If not, we need to install GitHub Desktop. If you are using a Windows machine, please try to install the Git software or GitHub Desktop software. Clear?
Okay.
So I will share a document on how to install Git or GitHub Desktop. Please follow that and try to install it. So that we can see some commands and we'll execute and see.
Okay.
Okay then. That's it for today. Thank you.
Yeah, thanks.